In this first example, I'm going to show you the NOT logic gate. So here are the electrical signs for this. Now let's call the input A, and the output will be the complementary of A, and you can also write this as A bar. Now let's draw the truth table, the input and output. If the input has a value of 0, the output will be 1. And if the input has a value of 1, the output will be 0. It's always gonna be on the opposite. If the input is in the off state, the output will be in the on state. Now how can we represent this using a transistor circuit? So in here we have the voltage source, and on the left we have the input, and the emitter is attached to the ground, but the LED will be connected across the collector of the transistor and the emitter. In this part is the LED, and it will be the output. Let's say if in the circuit or the input A is on the on state, will the LED be in on state or off state? So once we apply a voltage to the base of the transistor, current will be able to flow in the collector to the emitter. The current will flow from the positive 5 volts, and once the current comes to this position, the current can either flow from this point or from this point. Now electricity will always take its path of its existence. So if our transistor is on, the current will only flow from the collector to the emitter. So therefore, no current will flow in this direction, so it will be in the off state. Now let's say if we have an off state to the transistor, the current will still flow from 5 voltage source, and when it comes to this position, the current has no choice to flow from the collector to the emitter, because since the transistor is in off state, it will go through the LED and it will be in on state. Just like if we have 0 in the input, the output will automatically be 1. And if the input has a value of 1, the output will be 0. It always gets to the opposite. And that is our logic gates for NOT. And here is the sample for AND gate. We're gonna have two inputs, A and B, and the output will be A times B. Now let's make a truth table, and at the same time, let's draw the transistor circuit. So we're gonna need 2 transistors as opposed to 1. So this is input A and this is input B, and let's connect it to the voltage source. So what can happen if input A and B are in off state? Will the LED be on or off? So in this case, both transistors are in off state, so no current can flow from 5 voltage source to the ground. So therefore, the output will be 0 because the LED is off. Now what if A will be in on state and B will be in off state? Will the LED be on or off? Current will flow to the LED and current will flow to the transistor A. However, since transistor B is off, no current can flow to the ground. Therefore, the output will be off. The only way the LED can be on is if the A and B will be on. Only under that circumstances, a current can flow through the LED and flow to the ground. That's why we have AND. The only way the output can be in an on state is if the inputs A and inputs B are in on state. Even if B is on and A is off, no current can flow to the LED. Only if A and B are on. Now let's move on to the OR circuit. Let's say this is input A and B, and the output will be A plus B. Now let's make a table just like before, and let's draw a circuit that corresponds to it. This time we're gonna make two transistors, but they are gonna be connected parallel to each other to make the OR logic gates. In the case of AND logic gate, they were connected in series of each other. And so that's the key difference between the AND and OR logic gate. Now let's say that A and B are in the off state. Will the LED be on or off? So clearly, no current can flow to the first transistor or even to the second transistor. So therefore, no current will flow through the LED and the LED will be off. What about if the first transistor is on and the second one is off? What will happen? Current can flow to the resistor through the LED into the transistor that is on. Therefore, there is a path from the positive voltage source to the ground. So the LED will be on. Now what if transistor B is on and transistor A is off? Current can still flow to the resistor through the LED, but this time to the transistor B. So therefore, the LED will be on. Now what if the A and B are both on? The LED will definitely be on. The current will flow through the LED, through the first transistor, and the second transistor to the ground. So that's we have the OR logic gate. The LED will be on if A or B is on. And that's how to remember the truth table in OR logic gates. It doesn't matter whether A or B is on.